Okay, so I think recording has started. So today we have this problem named planar reflections, and we are going to be discussing this problem. And so let's get started. So we are given this problem statement. Gaurang has grown up in a mythical universe. He is faced by n consecutive 2D planes. He shoots up a particle of decay age k at the planes. A particle can pass through a plane directly. However, every plane produces an identical copy of the particle going in the opposite direction with a decay age k minus 1. Okay, if a particle has a decay age equal to 1, it will not produce a copy. Okay, for example, if there are two planes and a particle is shot with a decay age 3, then the first plane produces a d2 to the left and lets d3 continue on the right. Okay, and so on. Okay. In total, the final multiset S of particle is this. So by multiset, it's talking about the total particle that will remain in the end. Gaurang is unable to cope up with the complexity of this situation when the number of plane is too large. Help Gaurang find the size of the multiset S. Given n and k, since the size of the multiset can be very large, we have to output it modulo 10 to the power 9 plus 7. Okay, got it. So we have these constraints. The test numbers are about up to 100, and the number of planes and the energy of the particle would go from 1 to 1000. Okay, so let's switch over to the whiteboard. And okay, we have also an image here to explain the scenario. So we can see that we are getting a particle D3, and when the particle hits the plane, a particle of the energy, for example, let's just say this particle is having an energy k. So this particle will be having an energy k minus 1. Similarly, when and this particle d3 will pass to the another plane, okay, and then if we and this will also hit the plane 2, and another particle of k minus 1 energy, having k minus 1 energy, will get created. Okay, after that, when this particle hits plane 1, then a particle of d1 will also get created. And since this particle is having an energy k is equal to 1, therefore it will not split further. Okay, got it. So let's move over to the whiteboard and draw an example. So let's say this is plane 1, plane 2, plane 3, and so on. Okay, since it is hitting this, pardon me if I make any mistakes. It's been a while since I've used this, trackpad or writing pad, whatever. Okay, so k is equal to 3. A particle is having k is equal to, or let's just say it is alpha. And this will pass here. Another particle having alpha is equal to 2 will get created. Alpha, by alpha I mean energy. Okay, my writing sucks. No problem. Okay, so alpha is equal to 2. Now, since this particle is going to this direction, it will go on to the infinity. It will not split further. Okay, got it. So we can see that this is going in the direction of a recursive function. We can write a recursive function where we can say that, for example, let's just say we have a function named rec. Okay, let me switch over to the you know ID for better function definition. Okay, so let's just say we are having, I'm just writing a pseudocode to make you guys understand. Okay, so we have this int I, okay, and int k. Okay, let's just say k is an energy. K is the energy of the particle in a state, okay, and an integer d. Okay, so these are defining a particular state of a particle. So we can say that a base condition for this recursive function can be if I is equal to -1 or I is equal to n. We can say that return 1, okay, since this particle won't split further. And yeah, I don't think we need a direction, but we'll be needing it down the line. Okay. So if I'm writing a plain recursive function, then I can say this can be my base case. And if a particle hits uh, or or there is another condition where k is equal to 1. Since if, for example, if a particle will be having energy is equal to 1, it won't split further, of course. Okay? Okay. So, for example, let's just move over here. Okay. One second. Okay, got it. So now we can see that we have covered our base condition. Our recursive calls will be like if I think we'll be needing direction here. Okay. For example, if we are having uh, a d is equal to 1, then we'll add the particle. It will go on with the energy k, and it will be uh, going in the positive direction. Similarly, another particle will get created and it will be having a negative direction, and it will be having uh, it will be going in the, let's just say 0 will be denoting the negative direction, and it will go to the plane I minus 1. Okay. Okay, but here, as you can see, that this problem, if it didn't have this much of constraints, then this could be solved by this recursive function. I'm not extending it currently. I just wrote the pseudocode. But for example, if you can see that for a particular plane, our particle is being divided into two particles. Okay, first one is going to the another plane, and the second one is going to the another direction. If we go down the line, and if the energy of the particle is much higher, and it is between, let's just say n by 2 of the planes, then you can say that you can see the pattern, right? It is like this. One second. It's going exponential. Okay? It's being divided like this. It's being divided like this, right? For every particle having uh, an energy k is producing two particles uh, when it is hitting a plane, and those two particles are splitting into two another particles, right? Okay. So what can we do? Uh, what can be done? So if you can see the pattern, I think it's pretty much visible. it's going towards caching, or let's just say dynamic programming, right? How so? Okay. For example, let's just say if a particle is hitting this plane, right? Plane 3, let's just say. Okay. So it will be having a state. So the state of the particle will be, one second, let me just switch over to the ID. Uh, okay. So the state of the particle will be, this will be plane number, and the another one will be energy. Okay. And this will be direction. So I think we can pretty much capture the state of the particle by this array, this state, right? Okay, DP state. So what should we do? We'll be moving forward with this, and let's just try to write the code, and let's just see if it works or not. I think it will pretty much work. Uh, okay, cool. One second. Hmm. So I'll be writing the code from scratch. So int tests, say in tests while tests are greater than 0. Okay, and tests is equal to minus 1. Okay, void solve. Okay, and for every test we'll be calling this solve function. Okay, okay. So what are we having here? Okay, int n k, and okay, cin for every, one second. Okay, for every test case, we are given two integers n and k, where n is denoting the number of planes, k is denoting the, what is k denoting? Okay, the age of the particle, right? Okay, so cin n k. Okay, and we'll be defining the DP states here, the DP array. So since we are maximum having 1000 number of, planes, so I'll just say this much, and the energy of the particle can be up to 1000. So I'm giving it 1001, and the direction can be, only two directions are there. So I'll be giving this two. The 0 will be denoting the negative direction, 1 will be denoting the positive direction. Okay. Okay. So let's just initialize our DP array by -1. I think this is how memset work. Memset DP DP memset. One second. It's been a while since I've coded in C++, so pardon me. I'm just forgetting some nitty-gritties. One second. Memset. Okay. One second. Memset. Yeah, I think it's initialized like this. Okay, cool. Now I'll be writing my recursive function here, int rec, int I, int k. Should I call it k? No, let's just say e. Okay, int d. Okay, and let me just define it globally. I don't want to, unnecessarily pass it to the function. Uh, we're not coding in an interview setting, so yeah, why bother? Okay, if I is equal to -1 or I is equal to n or okay, or e is equal to 1, then we will be returning 1. Okay, if dp of I, e, and d is not equal to -1, since we have initialized it with -1, then we'll be returning. If it is not equal to -1, then we can say the answer is calculated for that state only, right? Okay, so dp of I, e, d. Okay, okay, cool. So now I'll be uh, calculating the answer for this particle, the particle having which will be hitting ith plane. It will be having an energy E, and it will be having a direction of D, right? Okay, so let's just 1 second. Okay, int answer. No, no, no. Let's just say if D is equal to 0, right? There can be only two direction. So I'll be starting off with this int answer. Let's just define our answer and what I'll be returning. I'll be returning the answer for this particular state. So before returning, I'll be saving it. dp of I, E, and D is equal to answer, right? Okay, okay, cool. And for example, now we only have two cases, right? So answer will be red. Okay, since it is having a direction D, then a direction of 0, then it will be hitting from this direction, right? The opposite one, this one. Okay, so it will create a particle of this as well, and this will go on. Okay, okay. So int rec I minus 1, it will still contain energy E, and it will still be having the direction D, plus rec and I plus 1, E minus 1, and D. Okay. Similarly, uh, this if D is equal to 1, then the particle will be going to the I plus 1th direction, and it will have an energy E, and the another one will be going to the opposite direction, and it will be having the energy uh, E minus 1, right? Okay. And since we have to output it modulo 10 to the power 9 plus 7, then let's just do it. Okay. So 1 second. Hash define. Okay. Uh, mod 1, 2, 3, 4, 5, 6, 7, 8, and 9. I think we have got this. Okay. I think macros work like this. Macros in C++. Earlier I used to use template. Oh, yeah, I mean, okay. Okay, got it. Mm, well, let's just say that once again. Let me define it here instead of, it will be better. And mod. Okay. So I'll be outputting it modulo 10 to the power 9 plus 7. So since the answer is large, so the judge is telling us to output it modulo 10 to the power 9 plus 7. Okay, so now let's just see out our answer. Rec 0, it is having an energy of K, and I think, yeah, I'll be shooting it into the direction of, it will be having direction is equal to 1, right? And yeah, cool. So let's just compile our code. Let's just see if it runs or not. Hope it runs. Oh, 1 second. For some reason, it is outputting 5312. Hmm. 1 second. Okay, okay, okay. Got it. So here, if the direction D is equal to 0, then another one will be having the direction is equal to 1. Similarly, here it will be having the 0th direction. Okay, so that must be the issue. I think it should be sorted right now. Okay, so we have got our answer 4312. I think let's just copy this test case as well and let's just see if it works or not. Then we'll submit it and we'll see if it runs on system test cases or not. I think it's pretty much sorted. Let's just run our code on the system test cases. We are using GNU G++17. Just submit it. It got accepted. So yeah, folks, I think it's a decent problem if somebody is getting started with dynamic programming. And yeah, so see you soon, guys. Bye bye.